everyone. Welcome back to our IGCSE Mathematics past paper walkthrough sessions. Um, I'm Hayan and I'll be your video host for today. While I'll be a video host, Varshini, our amazing contributor, will be guiding you through all the key things and key strategies you need to know to tackle the paper Summer 2022, Paper 2022. So are you ready? Let's get started.
Hi everyone. So as Hyan said, today we'll be doing Summer 22 Paper 22. So this is the first question. At noon, the temperature is 4 degrees Celsius, and at midnight, the temperature is minus 9 degrees Celsius. Work out the difference in temperature between noon and midnight. Okay, so we know that the word difference means subtraction. So what we need to do is subtract the temperatures to find the difference between them. So all we need to do over here is we take the first temperature 4 and subtract minus 9. Don't forget we need to subtract minus 9, not just 9. So it's going to be minus 9. And we know that a minus and a minus is a plus, so we can make this 4 plus 9, and we will get 13 degrees Celsius. Okay, question number 2. Thibault records the number of cars of each color in a car park. So there are 4 colors here. There's black, white, silver, and red. And 8 black, 5 white, 4 silver, and 3 red. He draws a pie chart to show this information. Calculate the sector angle for the red cars. Okay, so we know a pie chart looks somewhat like this with all the different sectors, and there are 4 sectors. So let's say, and each sector would be a color, so they just want us to calculate one sector angle. So we know that the formula for the sector angle is similar to the formula for a percentage. We know it's nothing but part by total into 360. And in this case, we're doing it for the red cars. So red over here, as you can see, is 3. So that would be 3 divided by the total, which would be black plus white plus silver plus red. So let's add those up in our calculator. So that would be 8 plus 5 plus 4 plus 3. So you can just put this directly in your calculator and don't forget to add the brackets. And again, multiply it into 360. So if you put this in your calculator or do it manually, but always make sure you recheck, you should get 54. So 54 is our answer. Okay, question 3. Figs cost 43 cents each, and Lyra has $5 to buy some figs. Calculate the largest number of figs Lyra can buy, and the amount of change in cents that she receives. Okay, so first of all, we have cents and we have dollars here. Since they want us to calculate everything in cents, we're going to have to change all the units to cents. So we know that $1 equals 100 cents. And so $5 is going to be 5 into 100 cents. So we can make this 500 cents. Okay, now we want the largest number of figs that Lyra can buy. So to do this, we know that each fig is 43 cents and she totally has 500 cents. So we're going to divide 500 by 43. And if you put that in your calculator, you should get 11.6279 something. Okay, but first of all, remember, we want the amount of figs she can buy in the chain. So she obviously can't buy 11.627 figs because figs only come as whole. So we know that the largest amount is 11. She can't buy any more than 11 because she gets 0.627. So we can write this over here as 11. Now for the change she gets, we know that 6279, this 0.6279, this number, uh, once we take out 11 from this, she's going to have theoretically, she would have 0.6279 figs left over. So all we need to do is convert 0.6279 into cash. So to do this, we know that each fig is 43 cents. One fig equals 43 cents. And so 0.6279 figs would be 43 into 0.6279 figs here. So you can just put the number you've generated already, just put that direct large decimal, just put that in your calculator. Sorry. Yeah, so and don't forget to 11 minus, 11.6279, your large answer. Subtract 11 from that because we want the leftovers. That's not part of the whole number. And then multiply that into 43. And you should get 27 exactly. So 27 is the change she has left over. Okay, question 4. Find the value of root 68 into root 153. Okay, so to do this, all you need to do is directly put it into your calculator. You could also just okay. So you have the square root button, just put 68 into root 153 on your calculator directly. You don't need to show any working for this, it's only 1 mark. And you should get 102. Additionally, if you want, you could write this as the whole root of 68 into 153. Because we know that for when we're multiplying any roots, we can just multiply the numbers inside and put a large square root on top of the whole thing. Okay, question 5. Find the total surface area of a cuboid with length 8 centimeters, width 6 centimeters, and height 3 centimeters. Okay, so to get some clarity, let's draw the cuboid first. Okay, so our cuboid is going to look something like this. This being the front. Okay. And the other face being the back. So we know the length this side is going to be 8. We know the width this is going to be 6. And the height over here, this length is going to be 3. So and they want us to find the total surface area. So what we need to do is calculate each face side. So first we have this face, this front face. So we can easily make that 3 into 6. We know that's just going to be width, base into width. Okay, for all the faces, it's going to be base into width. Okay, plus, now let's calculate this face on top. This is going. We know that over here, this bottom part is 6, and we know the length is 8. So that's going to be 6 into 8. And we can say that into twice because of this bottom face on the bottom, which is the exact same thing. So into 2. And we know that over here, the 6 into 3 that we've already done is also going to be into 2 for this face. So let's just add in into 2 over here. And lastly, we have the side faces. Let me use a different color. Yeah, so this face, let me tilt this. Yeah, and the other face that's on the other side of that. This, it's a little difficult to draw, but over here, this face. So, in a sense, this face on both sides. Okay, so that would be 8 into 3 into 2. So plus 8 into 3 into 2. Okay, so all you need to do now is put that in your calculator. and you should get a 180. Let me just double check and make sure you add the brackets when you do this. Yeah, you should get 180. Okay, the next question, question 6. Some cards have either a square, a circle, or a triangle drawn on them. Piet chooses one of the cards at random. Complete the table to show the probability of choosing a card with each shape. So here we have square of 0.2, circle of 0.32, and triangle of, we don't know what it is. But we also do know that the total probability is always equal to 1 out of everything he chooses. So that means this probability of a square, which is 0.2, plus the probability of a circle, which is 0.32, plus the probability of the triangle, which we don't know, so we'll make this x, is going to equal to 1. So now to find x, all we have to do is subtract 0.2 plus 0.32 from 1. So now that we have this, we're just going to do 1 minus 0.2 plus 0.32. And if you just put that directly in your calculator, you should get 0.48, which is our answer. So we're just going to write it over here. Okay, for the next question. The price of a coat is $126. In a sale, this price is reduced by 18%. Find the sale price of the coat. So all we need to do really is find the final price, and we know the initial price is 126. So we can say sale price SP is going to equal to original price into 1 minus our loss in percentage, which we have by 100. Okay, yeah. So this is our formula. And we know the original price here is 126. So 126 into, now we also know that's getting reduced by 100. So this is why you'll do 1 minus and not 1 plus, because if it's getting increased, then you're going to do 1 plus, but this is getting reduced. So we have to make this into 1 minus the loss, which is 18% here. Remember, and percent is by 100 always. Right. So if you put this in your calculator directly, and don't forget to add the brackets and the fractions and everything, you should get 103.32. And for these questions, remember, don't round it off to 3 significant figures for these percentage losses and percentage questions, because they want your full answer. Okay, question 8. The nth term of a sequence is n squared plus 12. Find the first 3 terms of the sequence. Okay, so we know that n is the term we want. So for the first term, we just have to substitute 1 into n. That's going to be 1 squared plus 12. For the second term, we have to substitute 2 into n. That's going to be 2 squared plus 12. And lastly, for the third term, we substitute 3 into n. That's going to be 3 squared plus 12. So now, all you have to do is put all these values in your calculator. So 1 squared plus 12 is going to be, or you could do them manually, is going to be 13. 2 squared plus 12 is going to be 16. And 3 squared plus 12 is going to be 21. Okay, the next question, question 9. They've given us a diagram, and they've said the bearing of B from A is 0.59 degrees. Work out the bearing of A from B. Okay, so we know that the bearing of B from, we know that for a bearing, if this is, one sec. We know that for a bearing, if this is north, the bearing is going to go clockwise. It's going to be the full thing. Okay, and they're saying the bearing of B from A is 0.59. And we know that bearing is always straight from north. And when they say from A, that's where we take it from. We don't take it from B, we take it from A. So for example, in this one, it would be this much because we're going to go clockwise and start from north. So you're saying this much is 59 of B from A. Work out the bearing of A from B. So to do this, first we need to draw a line north. Just draw a straight line north. And this is going to be parallel to the other north obviously. Now they want the bearing of A from B. From B is the keyword. So remember, again we start from B and we go clockwise till we reach A. So this is the angle we want. So how do we calculate this angle? Firstly, we know that an angle in a circle, like this one over here, is going to be 360 degrees. And we can also find, and we also know that this entire angle over here is nothing but 360 minus this angle. And now to get this angle, which let's write it as NBA, we know that, so we can, first of all, let's extend this line over here. And we know that angles in a straight line are always 180 degrees. And therefore, this angle over here must be 180 minus 59, which is going to be 121. 121. And we also know that this angle, NBA, is the opposite interior angle of 121, because we can clearly see that as these lines are parallel, is these lines, sorry, of 59, these lines are parallel, these two norths, and so this NBA is going to be equal to 121. So we can write NBA equals 121. Now remember, they want the bearing of A from B, which is going to be, as we calculated, 360 minus 121. Now if you put that in your calculator, you should get 239 degrees. Degrees won't be in your calculator, but remember it's a bearing, so we always write it in three figures and degrees. So 239 degrees. Okay. Okay. Question 10. So they've given us two vectors. We can see first is p equals 2 and 8. So how do we look at this? We know that the number on top, this one, is going to be how much it's moved in the x-axis. And the number on the bottom, this one, is going to be how much it's moved in the y-axis. It's a y-coordinate. Okay, so for example, if we drew the x coordinates and the y coordinates, p would be 2 along the x-axis and upwards 8 somewhere over here along the y-axis. This would be p. And q would be -1, which means you go to the left instead of the right. And then again, 4 up. 1, 2, 3, 4. Q. Okay, so now firstly they want us to find p minus q. So we know when we subtract vectors, we have to subtract both the x and the y from the other vector. So over here that's going to be 2, 8. My bad. Minus -1. And also 8 is going to be -4. Don't forget the -1 over here, which is already in q. So now we know that minus minus is a plus, but you could also just put it right in your calculator just to double check. And on the top you should get 3, and on the bottom you should get 4. So we'll just rewrite this in these brackets. Okay, so next they want 6p. So we know that we multiply a vector, again we have to multiply both the top and the bottom. So 6p is going to be equal to 6 into 2 and 6 into 8. So that's just going to give us 12 and 48. And remember, these are vectors, they're not fractions, so we can't simplify the fraction. We can't divide 12 by 48 and say what it's and make it 3 by 4. They're vectors, so we have to keep this as 12 and 48. Okay, for the next question, find p minus q, and they've given these lines at the side. That means when they have these lines, that they want us to find the magnitude of p minus q, not just p minus q. So first, we already found p minus q. We know it's going to be 3, 4. 3, 4. And my bad, 3 and 4. And we already know that this is in the x-axis and this is in the y-axis. We also know that for any vector, the formula to find the magnitude is nothing but the root of the x-coordinate squared plus the y-coordinate squared. So that over here is going to be the root of 3 squared plus 4 squared. And if you calculate that, that should just give you 5. I mean, you could also just, if you know the triplets in Pythagorean theorem, you should know that 3 squared plus 4 squared equals 5 squared. But if not, no worries, you have a calculator for this paper. Okay. Okay, 11. Find the value of p when 6 to the power p into 6 to the power 4 equals 6 to the power 28. Okay, so first we know that from the laws of exponents, whenever we have a to the power n into a to the power b, let's say, this is just going to give us a to the power n plus b. So we can rewrite this 6 into the p into 6 to the power 4 as 6 into the power p plus 4 is equal to 6 to the power 28. And we also know over here that when we have a to the power n equals a to the power x, n is going to equal x. So in this scenario that we have here with 6's, we can say that the powers are going to be equal. So we can also say that p plus 4 equals 28. Now all we have to do to find p is subtract 4 from both sides, and we get p as 24. Okay. Question 12. Annette cycles a distance of 70 kilometers from Midville to Newtown. Leaving Midville, she cycles for 1 hour 30 minutes at a constant speed of 20 kilometers per hour and then stops for 30 minutes. She then continues the journey to Newtown at a constant speed of 16 kilometers per hour. Okay, so on the grid, draw the distance time graph for the journey. So we want everything in terms of distance and time, which is hours. So first, let's look at this. We know that her total distance is going to be 70 kilometers. So at the end, hold on, this is 80. And so first let's look at the boxes. So on the y-axis, we can see that for 20 units, for 20 kilometers, there are 10 boxes. So one box is going to be equal to 20 by 10, which is 2. And on the x-axis, we can see that for 1 hour, there are 10 boxes. So one box is going to be equal to 1 by 10, which is 0.1 hour. Okay, so now let's look at the first piece of information. So she cycles for 1 hour 30 minutes. So we know that 1 hour 30 minutes is 1.5 hours, which is 1.5 hours. And so that's over here we have 1, and so 0.5 more of an hour. So that's just going to be 5 of these boxes. 1, 2, 3, 4, and 5. Over here will be 1.5 of an hour. She cycles for this at a constant speed of 20 kilometers per hour, and she stops for okay, so we know that over here we know that over here we want the distance. So we do know that distance is equal to time into speed. And we have the time and we have the speed. We have the time as 1 hour 30 minutes, which we know is 1.5 hours. So let's make this 1.5 into her speed, which is 20 kilometers per hour. So if you multiply these, you should get 30. So we know that for 1.5 hours, at the end of 1.5 hours, she cycled 30. So let's find 30 over here on the y-axis. It's going to be half in between 20 and 40. So let's just count 5 of these boxes again. 1, 2. So this is 22, 24, 26, 28, and 30 is going to be over here. So now we know that at 1.5 hours, she has cycled 30. So we can make this point. And it's at a constant speed, so we know the graph is going to be a straight line graph. So we can draw the graph like this. And by 1.5 hours, she's at 30 kilometers. Okay, so now she stops for 30 minutes. That means her distance is not going to change for 30 minutes. It's going to be the same. And for 30 minutes, we know that she's going to be till 2 over here, because 1.5 plus 30, 1.1.5 hours plus 30 minutes will give us 2 hours. So we can draw the line over here like this. Okay, another last part. She then continues the journey to Newtown at a constant speed of 16 kilometers per hour. So for this, we know that the distance, we know how much distance she's already gone, which is 30. And we know the distance she has left. We know that the total distance is going to be 70. So we know the distance left is going to be 70 minus 30. And this is 40. So she has 40 kilometers left to go to Newtown. Okay, and we also know that all of this 40 kilometers is going to be at the speed of 16 kilometers per hour. So again, using our distance equals speed into time formula, we can calculate, now we need to find, actually we don't need to calculate this last part. We do know that she's going to end up at 70. So 62, 64, 66, 68, and 70. We know she's going to end up here. And we know she's just cycling a constant speed from there, from where she left off, which is over here. So we can plot this point. We do need to calculate the time. Sorry, my bad. So we also know that time equals distance by speed. And over here, we just need to put in her distance, 40, by the speed, which is 16, constant speed. So 40 by 16 is 2.5. So it means she's traveling 2.5 more hours for the speed. So and over here it's already at 2. So it's not going, the total won't be 2.5, but 2.5 more than 2. So that's 2.5 plus 2, which is 4.5. So that's going to be over here, the mid in between 4 and 5. If you want, you can count the boxes 1, 2, 3, 4, 5. And we know at this point she's going to reach her destination at 70. So use your scale and trace the line all the way down from here to 70, which is right here. And make sure you've got the values right. Okay, so mine is a little high, so I just need to put this down. And okay, that's still high. There, okay. So that would be at the point she's at. So now we can draw an X over here. Get rid of this. Now we just need to draw her final line, which is Yeah, just make sure you're using a scale when you trace these. And make sure it ends at the right point. Okay, so there we have our distance time graph. Okay, part B, calculate the average speed for the whole journey. So remember, they want the average speed for the whole journey. So that is just going to be our total distance by our total time. And we can also see that they want it over here in kilometers per hour. So our total distance, we do know, we can look at, we've seen over here that it's 70 kilometers. So that's going to be 70 kilometers divided by her total time, which over here, as we can clearly see, is 4.5 hours. And we'll make this 4.5. Um, yeah. Okay. Um, if you put that in your calculator, you should get 15.55 something. And if we round this off to 3 significant figures, we're going to get 15.6. Remember, we need to round it up from 5. Okay, question 13. Without using a calculator, work out 4 1 by 8 minus 2 and 5 by 6. You must show all your working and give your answer as a mixed number in its simplest form. Okay, so remember, we can always use our calculator to recheck our working in these questions, but we do need to show all our working. So first, let's convert both of these mixed fractions to improper fractions. So we know for that, we're just going to do first, let's do 4, we're going to do 4 into 8 plus 1. So that is going to give, you can just put that in your calculator if you want. And or you could do it. And it's going to be 33 divided by 8. Now minus the other improper fraction, which is going to be 2 into 6 plus 5. So that is just going to be 17. So minus 17 by the same denominator, which is 6. And now we can clearly see that our denominators are different. So we need to make them the same. And so we need to find the common denominator, which over here you can just do trial and error to see if you want to find it, but it's going to be 8 into 3 and 6 into 4, which is when they first have the common fraction. So that means we're going to have to multiply this fraction into, we're going to have to multiply the numerator into 3 and the denominator into 3. We're going to have to multiply this numerator into 4 and this denominator into 4, because we know that 6 into 4 equals 8 into 3. Okay, so now if you just do these in your calculator or manually, it doesn't matter. You should get 99 divided by 24 minus 68 divided by 24. And now that these have the same denominator, we can go ahead and subtract their numerators and make this 99 minus 68 divided by 24. And again, put this in your calculator or don't, but you should get 31 by 24. Now remember, they want it as a mixed number, not an improper fraction. So we're going to go ahead and do some long division. So 31 divided by 24. So 24 is going to go one time into 31. And down there it's going to be 7. So now we have this. We know that to write this as a mixed number, we do the top, which is 1 and 7 by 24. So it's going to be 1, 7 by 24. And that is our final answer. And if you're unsure, you can always, put the initial thing, this one in your calculator and recheck your answer to make sure it matches. Okay, question 14. Carlos invests 4540 at a rate of R% per year in compound interest, and at the end of 10 years, he has earned 1328.54 in interest. Calculate the value of R. Okay, so firstly, we know that for any compound interest, we know that the formula of the amount he's earning is going to be the principal, the amount that you invest, into 1 plus R by 100, and R is the interest you have, to the power of n, which is n is being how many years you've invested it for. But here it says that he's earned 1328.54 in interest. So that means he hasn't earned it his total amount isn't 1328.54, but his interest is 1328.54. So this amount over here that we're getting is going to be the initial amount he invests plus the interest. So to find just the interest he earns, we're gonna have to do 4540 to get his amount, which is just get the interest. So we subtracted 4540. So now to find the amount, we're gonna have to add 4540 to what he's earned, 1328.54. So let's now substitute in all the values. So we know that the amount over here is going to be 1328.54 plus 4540 is equal to the what he's invested, which over here is going to be 4540 into 1 plus R, which we don't know, by 100, to the power n, and n over here it says 10 years. So we know he's been investing it for 10 years. Yeah. Okay, so now to calculate the value of R, all we need to do is move everything to the other side to make R the subject of the formula. So first, let's get rid of 4540 by dividing both sides by 4540. And now we have this to the power 10. We know that since it's to the power 10, we need to root both sides by 10 to get rid of it. So we can just cancel this out by rooting it to 10 and root this full thing to 10. So first, and once we do that, we're still gonna have R by 100. Sorry, 1 plus R by 100. So we need to get rid of 1 over here. So it's going to be 10th root of 1328.54 plus 4590 divided by 4590. So we have that, and then we're gonna have to minus 1 from that, and then multiply that full thing. Okay, so first let's calculate this in our calculator. Make sure that you put the 10th root and not just the square root. Plus 4590 divided by 4590. And you should get some number, 1 point something. And now let's subtract 1, and don't round it off in your calculator, keep the exact value, because like every decimal place matters in these types of questions. So now subtract 1 from the value that you got. Okay. 0.0 0.025. You should get something like this. Okay, and now that we have this, we know this is equal to r by 100. So now to get rid of the 100, all we have to do is multiply both sides by 100. Okay, so when you multiply both sides by 100, we're going to get 2.57. Okay, so to write this in three decimal places, 2.5, I mean, it's 2.574, but we're just going to write this in two decimal places. Okay, which is going to be 2.57. Okay, for the next question. 15. Find the highest common factor of 12a cubed b and 20a squared b squared. Okay, so that means for these numbers where we have three different variables, like a number a and b, we need to find the HCF of the number and a and b and just put them all together. So first, let's find the highest common factor of 12 and 20. So we know, let's look at the factors of 12. Okay, there's 2 into 6, there's 3 into 4, and there's 1 into 12. And now let's look at the factors of 20. There's 20 into 1, there's 4 into 5, there's also 10 into 2. Okay, so let's look at now the highest number that comes in both of these, and 2 comes in both of these, but so does 4, and 4 is bigger than 2. So we know that 4 is going to be the highest common factor in both of these. So let's write 4 over here. Now, for a cubed and a squared, we know a cubed is nothing but a into a into a, and a squared equals just a into a. So the highest common factor between these is just going to be this, a into a, because we can see that it's a cubed is nothing but a squared into a, and a squared fits perfectly into a cubed, so a squared will be the highest common factor. And now for the b term, we have b and we have b squared. Again, b squared is nothing but b into b, and we can only take one b from this. There is only one, I mean, essentially, that we know of, one factor of b that is written in terms of b, and that is b. So that's the only factor we can take, which is going to be b. So there we have our factor our highest common factor for a squared b. Okay, the Venn diagram shows the number of students in a class of 40 who study physics, mathematics, and geography. Use set notation to describe the shaded region. Okay, so the shaded region is the whole of G. We can see it's the whole of G and the whole of M except for P. So to write that in terms of set notation, we know that when you take the whole of both two things and combine them, it just G union M. And we know that this is intersecting with whatever is not coming into P. So whatever is not in P and whatever is in M and G, the intersection of that is M and G. If you're confused about this, you could also just draw it out and shade M union G, which would just be both of these circles. And now we can to find what else comes in here. If you shade everything that comes outside P, and let's shade it the other way. Everything that comes outside of P, everything not in P. It's going to be all of these little spaces, everything. We can see that the only places the lines intersect is the places they're shaded. So that means it's everything that comes in G union M, that intersects with everything outside of P, which we can write as P complement. And let's just add the brackets for extra clarity. So all we have to do is write this in set notation that intersects with P complement. Okay, part B, find the number of elements that comes in P intersection G, which also comes with that's also there in M complement. I mean intersection M complement. So let's just get rid of all of this shading. Okay, so now let's look at this. We firstly let's do this the same way we tackled the before question. Let's find everything that comes in M complement and let's shade it in M complement. That's everything that's outside of M. So let's just shade this like this. Everything outside of M. Oh wait, my bad. Yeah, everything outside of M. Okay, now we also want this along with this is union, the number of elements, I mean, whatever comes in P intersection G, and we know the intersection area between P and G is this bulb. Okay, so let's shade this a different way, like this. Okay, wait, no, that makes it impossible to see, so we'll just shade this. Okay, so for this question, they want the and they want everything that comes in M complement and everything that comes in P intersection G. So remember, a union is always and. Sorry, is always or, and the intersection is always and. So, and over here, everything that comes under P union G or everything that comes in N complement. So we have to take both the stuff that come in the intersection and the things that come in the complement. That means this 3 plus 5 region and the rest of this shaded region. So over here, let's just sum up the numbers that that are in the shaded region. So it's going to be 9 plus 3 plus 4 plus 6. And I mean, you could put that in your calculator, 9 plus 3 plus 4 plus 6, and you should get 22. 1 sec. Yeah, 22. Okay. A student is chosen at random from those studying geography. So they're only chosen from those studying geography. Find the probability that the student also studies physics or mathematics, but not both physics and mathematics. Okay, so we have our Venn diagram here, and they're saying out of this bucket, the students are chosen. So we only have to look at this, the geography bucket. So the student is chosen at random from this, and we want those. So we know the formula of probability is part by total, the part that we want by the total. So first, we know the total of everyone studying geography is going to be 3 plus 9 plus 5 plus 6. 3 plus 9 plus 5 plus 6. And I mean, we can totally see that from the circle. So that's going to be 23. You know the total here is 23. Now, what is the part we want? We want the students that study physics or math, but not both physics and math. So either they study physics or they study math. So the people in this 9 bucket, they come under the physics and mathematics. So we don't want those students. We only want this 3 bucket, these students who only study physics and geography. And this 5 bucket, the students who only study math and geography. So that's going to be 3 plus 5. So over here, that'll be 3 plus 5 by 23. And if we do that, we should get 8 by 23, which is our answer. And it's best to leave these as a fraction since they don't have a perfect decimal value. Okay. Part 17, sketch the graph of y equals sine x for 0 to x to 3, for x greater than 0 and x smaller than 360. So we know a sine graph is going to look like this, as opposed to a cost graph, which looks like this. And we also know that for the sine graph, we know that the end over here is going to be 360. And we know that the top value over here is at 1 and the bottom value is at -1. And they just want us to sketch the same thing. So all we have to do is sketch it. And I'm using a computer, so my values will be a little inexact, but make sure that your graph looks neater. And yeah, that is all. And also, we can also label these points. We know that this is half at half, and 360 by 2 is 180. So we can say this as 0, 180. And we can label this as 0, 360. And this, of course, is going to be 0, 0. Okay. So now let's go to the next part. Okay, solve the equation 3x plus 1 equals 0 for x greater than 0 and x smaller than 360. Okay, so first, we need to just make sine x. Hold on. We need to keep sine x on the side of the equation we want. So let's subtract 1 from both sides. 3 sine x is going to equal to 0 minus 1, which is just minus 1. And now let's divide both sides by 3. Okay, so now we have sine x equals minus 1 by 3. So now we know that for these questions, so if we look at the unit circle, we have A, S, T, C. And an easy way you could remember this is all silver teacups. So we know over here in the quadrant, and over here we can clearly see that the sign value is negative. And we know that only in A and S is sign going to be positive. So in both T and C, sign is going to be negative. So if we draw the value over here, our angle, in T it's going to be somewhere over here, and C it's going to be somewhere over here. So we have two values over here. So the C whenever sign comes in the C quadrant, it's going to be 360 minus the angle, which you can say theta, and over here is because we know that 1 full round is 360. Okay, and for the tan, the one in the tan sector, we know it's going to be 180 degrees plus the theta that we get. And now to find theta, all we have to do is do sine inverse of 1 by 3. Now we're already accounting for these negative values by finding them in the cos and the tan sector instead of the sine in the acute angle sector. So we don't need to take the negative of inverse sine 1 by 3. We just need to take inverse sine 1 by 3. And if you put it on your calculator, you should get 19.47. Okay, so now we're just going to do that plus 180 firstly. And you should get 199.47, which we're going to round off to 199.5. Remember, for this exam, we need to write all the angles in one decimal place, always, not three significant figures, but one decimal place. And for the next one, it's going to be 360 minus 19.47. And if you put that in your calculator, you should get 340.53, which again, we're just going to round off to 5. It's going to be 340.5. Okay, question 18a. Y is directly proportional to the cube root of x plus 1. So we know that when they say directly proportional, we know we can write this as y equals k, which is some number, into the cube root, okay, not the square root, the cube root of x plus 1. And we also know over here that directly proportional means k into this, and if it is indirectly proportional, it would be k divided by this cube root of x plus 1. Okay, we also have more information here. We know that when x is equal to 7, y is equal to 1. And they want us to find y when x equals 124. So first, let's find the value of k by substituting in these two values. When x is 7, y equals 1. So when y is 1 equals k into the cube root of 7 plus 1. Okay, so if you put that in your calculator, you should get 1 equals k into 2. Okay, and so k, let's get rid of this 2 by dividing both sides by 2. And we know k is going to be equal to half. So now we have k, we can rewrite what y is. Y is equal to 1 by 2 into the cube root of x plus 1. Okay, and now we want to find y when x equals 124. So that is going to be 1 by 2 into the cube root of, the cube root of 124 plus 1. And we know 124 is 125, and the cube root of 125 is 5. You could also, just put this in your calculator if you're unsure. So you should get 1 by 2 into 5. And we can write this as 2.5. Okay. Part B, f is inversely proportional to the square of d. So you know that this means f is equal to k divided by d squared. Remember, indirectly proportional means you're going to do the constant divided by what it's proportional to. And sorry, inversely, not indirectly, inversely. Explain what happens to f when d is halved. So we can rewrite this as f is going to be equal to k divided by, remember we're doing d by 2 because it's being halved, squared. Okay, so again, if we rewrite this again and expand this, we know that d by 2 squared is going to equal to k divided by d squared divided by 2 squared, which is 4. And this over here, we know that for whenever you divide an answer by a fraction, it's nothing but multiplying it into the reciprocal. So it's going to be k into 4 by d squared. So now we don't really care about d squared. We want to know what happens to f when d is halved. Okay, so all we have to do is move these two, 4 and k, to the other side. So we're going to divide the side by 4. Or, instead of doing that, we can also just look at this equation, f equals k into d squared by 4. And we do know that when you divide by d squared by 4, 4 is going to come in the numerator, like we said. K is going to be equal to k into 4 by d squared. And we can clearly see that it's the same thing as k by d squared, except, so when we compare these, hold on, let me get rid of all this. Yeah, d squared. So when we compare what we have here, k times 4 by d squared and k by d squared, we can see that the only difference is this new value is getting multiplied by 4. So we can say that f will be multiplied by 4. Okay. Okay, for the next question. 19. Find f inverse of x. So we know when we find f inverse of x, we need to replace f of x with x and x with y. So f of x is going to become x, and we have 7 into y instead of x minus 8. Now we need to make y the subject of the formula. So first we're going to add 8 on both sides. X plus 8 equals 7y. And lastly, to isolate y, we have to divide both sides by 7. And now we have f inverse of x, which is just x plus 8 by 7. X plus 8 divided by 7. Okay, part B, find the value of x when h of x equals g of 1 by 3. So first let's find g of, let's rewrite this. So we know h of x over here is 2 to the power x plus 1. So 2 to the power x plus 1 is equal to g of 1 by 3. And g of x is 4 by x plus 5. So 4 by x plus 5. And here it's g of 1 by 3. So we know we have to replace x with 1 by 3. So let's take this out to make this 1 by 3. We know when it's 4 divided by 1 by 3, it's nothing but 4 into 3 by 1. Okay, so now that we have this, all we need to do is make 2 to the power x the subject of the formula. So 4 into 3 is nothing but 12. I mean, just put this in your calculator, and 12 plus 5 is 17. So, so now let's move, hold on. H of, yeah. Okay, so now let's move, 1 to the other side and subtract it. So 4 into 3 plus 5 is 17, and 17 minus 1 will give us 16. Or you can just put it in your calculator. You can also rewrite this as 2 to the power x plus 1 equals 17. Now let's get rid of 1, subtract it from both sides. Now we have 2 to the power x equals 16. So now how do we go about this? So to find x, we need to make this 16 in terms of 2. And we do know that 16 equals 2 to the power 4. If you're unsure about this, you can just do trial and error in your calculator until 2 to the power 2, 2 to the power 3, and 2 to the power 4 until you get 16. So now we know 2 to the power x equals 2 to the power 4. And like we said for rule of exponents, if the bases are equal, and then the powers must also be equal. I mean, if you're equating the things. So that means x has to be equal to 4. Okay, question 20, factorize completely. 2m plus 3p minus km minus 12kp. Okay, so we have a few m terms and we have a few k terms. We have one k term. We have a few p terms. So wait, we do have 2k terms. Okay, so let's group the m terms together. My bad. Yeah. Let's group the m terms together. So it's going to be 2m minus 8km. And then let's put the rest of the terms plus 3p minus 12kp. Okay, so now that we have these two m terms, we can take the common multiples out. So we know that 2 into m is going to go once into m, and we also know that 8 is divisible by 2, and m is also divisible by m. So we can take 2m out over here, and 2m into 1 is equal to 2m, minus, and if we take 2m, 2 will go 4 times into 8, and m will go once into m. So that's going to give us 4k of what we have remaining after we've divided 8km by 2m. Okay, now let's take the rest of the brackets. We can see that 3 is a factor of 3 and 3 is a factor of 12 here. Over here, 12kp. So we can take 3, and p again is a factor of this term and a factor of this term. We can take 3 and p out, so plus 3p. And now let's divide, we know 3p by 3p is nothing but 1. And now minus, if we divide 12kp by 3p, 12 by 3 is 4, and k will not be divisible, so we have to leave this here. And again, p divided by p is just going to give us 1, so it's just going to be 1 minus 4k. Now we can't leave it here because we can see that two of these, 1 minus 4k and 1 minus 4k, is the same thing. So that means we can again factorize this and make this 2m plus 3p into 1 minus 4k. And you can rewrite it again in the blank. Okay, part B. We need to factorize this. 5x squared minus 20y squared. So we know that, first of all, this looks similar. First of all, we can take out 5. We know x squared and y squared don't go, but we do know that 5 goes into 5 and 5 goes into 20. So if we take out 5, we're going to get x squared, because if you divide x squared by 5x squared by 5, you'll get x squared. And if you divide minus 20 by 5, you're going to get minus 4. So it's going to be minus 4y squared. Minus 4y squared. Okay, now this looks similar to the formula. We also know that x squared minus y squared equals x plus y into x minus y. And x squared plus y squared looks very similar to this that we have over here, x squared minus 4y squared. The only thing is 4 isn't in terms of square, but we do know that 4 equals 2 squared. So we can rewrite this as 5 times x squared minus 2 squared into y squared. Now that we have these two terms in the same way format of x squared minus y squared, we can just replace it into this, x plus y into x minus y. So that's going to be 5, don't forget the 5 on the side, into x minus, remember it's not just y, it's 2y, because 2 is also getting squared. 2 is also part of this coefficient. Remember, we can't apply this unless the 2 is being squared. If it's just 2y, then we'll have to take it as a root of 2. Okay, yeah, but since 2 is conveniently getting squared here, we can make this 2y. Okay, now into the other term, which is x minus y. So that's going to be x minus 2y. Sorry, this one is x plus 2y. Or I mean, whichever one could be x minus plus 2y. And now that we have this, we can just write it again in the blank. X minus 2y. Okay, question 21. The nth term of a sequence is an squared plus bn minus 4. The first term is minus 3 and the second term is 2. Find the value of a and the value of b. Okay, so first of all, we know we have the first term and the second term, and we know we can just substitute these in. So if the nth term is 2, so let's take the first term. We know if n is equal to 1, when n equals 1, okay, we're going to take this case. Okay, we're going to make this a into 1 squared plus b into 1 minus 4, and they've given us the first term is 3. So we know that this full thing, a into 1 squared plus b into 1 minus 4, is going to equal minus 3. Now we can simplify this. We know 1 squared is 1, and b into 1 will just be b. Minus 4 is equal to minus 3. Now we can take minus 4 to the other side and put it with minus 3, because they're the terms without any coefficients in front. So if we add plus 4 to both sides, we get a plus b is equal to 1. Now, for the second equation, we also know that the second term is 2. So let's take the case of n equals 2, and let's substitute 2 in here. So we know a into 2 squared plus b into 2 minus 4 is going to be equal to 2. As I said, the second term is 2. So now again, let's simplify this. 2 squared is 4, so that's going to be 4a plus 2b equals, again, let's take 4 on the other side by adding 4, equals 6. Okay, so now that we have this, remember, we want to make this a simultaneous equation. To do this, we just need to subtract the other equation, but first we need to have a variable that we can subtract out. So at least if we're having 2b here, 2b in this other equation should also be there. 2b on this should also be 2b on this equation. So we can do that easily by dividing this equation over here by 2. Okay, so if we divide 4a by 2, it's going to be 2a, and 2 by 2, which is 1, so it's going to be plus b, equals, and 6 by 2, again, which is 3. So now we have b without any coefficient and b in equation 1. Let's label these equation 1 and equation 2. Now we can subtract equation 1 from equation 2. So let's make this minus a, let's put it over here, down here, minus a minus b equals minus 1. Remember, we're subtracting all the terms. So 3 minus 1 is 2. And now since we made the b's the same term, they'll cancel out. And 2 minus 1a is just a. Okay, so now we have a equals 2. So now to get b, we also know that over here we have said we can use any of our equations that we found. We know a plus b equals 1. And we know a is 2. So we can say 2 plus b equals 1. Now let's just move 2 to the other side to find b. b is going to equal to 1 minus 2. And that is nothing but minus 1. Minus 1. So b is minus 1 and a is 2. Okay, question 22. So they give us a vector triangle here, and they said that OA equals x, OB is equal to y, and OD equals 3 by 7. So OD, wait, hold on. Let's draw a line. OD is this length, and we know that OD is nothing but 3 by 7x plus 4 by 7y. Now they want us to calculate the ratio AD is to DB. So first, to do that, we need to find AD and DB. So we know for to find AD, we can literally just go backwards, down x, and up AD, which will give us the distance between the vector AD. So now we can we know it's first we're going to go down AO. Let me clean this up a little bit. Okay, so we're going to go down AO, and that's just going to be not x, remember, because you're going down and x is up. So it's going to be minus x. So let's do AD equals minus x plus, now we're going to go back up to D. Sorry, my line is a little wonky. O to D. Okay, and we know that OD, for fact, we know it's 3 by 7x plus 4 by 7y. So we can just make this plus 3 by 7x plus 4 by 7y. And we shouldn't leave it like this. We do know we have two x terms here, so we can simplify them. So in your calculator, just do minus 1 plus 3 divided by 7. You should get minus 4 by 7. So we can make this 4 by 7y minus 4 by 7x. So now let's find dB. So we know, okay, no, again, let me clean up this vector. Okay. So we know dB, to find dB, we have to go downwards from D to O first, and then back upwards from O to B to find dB. Okay, so first to go downwards, we have to find DO. So, and that is just going to be, remember, we're not going OD, we're going downwards again, so that's going to be minus of OD. So that is going to be minus 3 by 7x minus 4 by 7y. So now that we've gone down DO, we have to go up back to B. And we already know over here, they've said that OB is just y. So we can just do plus y. Now again, let's simplify these y terms. For minus 4 by 7 plus 1. So if you put minus 4 divided by 7, minus 4 by 7 plus 1 in your calculator, you should get 3 by 7. I mean, you could also do it logically. 1 minus 4 by 7 would be the remainder of 7 minus 4, which is 3 by 7. So now we have this equal to minus 3 by 7x plus, or we could write this with y first, as we did in the other one with y first, 3 by 7 y minus 3 by 7x. So now that we have 3 by 7, 4 by 7 in front of both of these, let's take out 4 by 7 in front. We know we can factorize this because 4 by 7 comes in both of these terms for AD. So let's make this 4 by 7 into y minus x. And over here in this other equation, we have 3 by 7 in front of y and x. So again, we can make this 3 by 7 into y minus x. So now we can see that AD to DB, so let me again clean up everything else. Now that we have what we need. Okay, now that we have what we need, we can see that, so this is AD, and this over here is DB. So we can see that y minus x and y minus x are the same, so we can literally just cancel them out. We know AD to DB is going to be equal to 4 by 7 is to 3 by 7. And again, 7s are both in the denominator, so this isn't relevant. They're the same thing. Just how we cancel out y minus x, we can cancel out 7. So AD to DB is just going to be 4 is to 3. Now let's get rid of this thing. We can write it here. 4 is to 3. Okay. Right, question 23. The diagram shows a solid metal shape made from a cone and a hemisphere, both with radius 6.2. So we know this much is 6.2, and we also know that this much is also going to be 6.2. All around, I mean, for this hemisphere, it's going to be 6.2. Okay, the total surface area of the solid shape is 600 centimeters squared, and they want us to calculate the slant height L, which is this, this of the cone. And they've given us two formulas. The surface area of a sphere is A equals 4 pi r squared, and the curved surface area of a cone with radius r and slant height L is pi r L. Okay, so we know r over here is equal to 6.2. And we know the surface area, all we need to do is to find these. We need to do surface area 1 plus the surface area of the cone plus the surface area 2 of the hemisphere. We can just equate this to 600. Okay, so how do we go about this? So first, let's find the surface area of the hemisphere. So they've given us the formula of a sphere, 4 pi r squared. Remember, it's a hemisphere, so we have to divide that by 2 because it's only going to be half the sphere. And we don't really care about the inside part. We only care about the outside part getting exposed. So that's just going to be 4 by 2 pi r squared. So 4 by 2 pi, and we know r over here is going to be 6.2. So 6.2 squared. Okay, that is our surface area of the hemisphere. And we also know the curved surface area of the cone, the full cone over here, our full thing. We know this is just going to be pi r into L. Okay, so we know that um we can just write this as pi into 6.2 into L. And remember, L is the variable we don't have over here. We need to find. So this is S area 1 and area 2. So now we need to add these and equate them to 600. So first let's find S1 and let's find S2. So S1, if you put that in your calculator, that's 2 into pi, and use the pi button always, 6.2 squared. And you should get some multiple of pi, which you can just leave as a fraction, 25 into pi. Sorry, just 25 into pi. Okay, and this is 1922 by 25 into pi. And now we have the surface area 2. Remember, we don't have L, so we'll have to leave this as a multiple of L. So we can just make that 6.2 pi into L. So now we know the sum of these are going to be, as they've given us, 600 centimeters squared. 1922 divided by 25 into pi. Pi. Okay, plus, our other number here is 6.2 pi L. 6.2 pi into L is giving us 600. So now let's get rid of 192 by 25 into pi by subtracting it from both sides. 1922 by 25 pi. And again, we need to get rid of this 6.2 pi to just find L. So we're going to have to divide. So now we just have this 6.2 pi into L is giving us this full thing. So all we have to do is divide both sides by 6.2 pi to make L the subject of the formula. And now you can just put this straight into your calculator. 600 minus 1922 pi 25. And divide that full thing by 6.2 into pi. And you should get 18, hold on, zoom this out, equals 18.404. And remember, again, always add this to 3 significant figures. So we're going to round this off and make this 18.4, which is our answer. And this is our last question.
Thank you, Varshini, and thank you everyone for listening to this video. Um, Please don't forget to hit subscribe to get updated for more sessions on this series. Goodbye and see you in the next video.